Hi, in this video we are going to talk about Deque in C++ STL. Deque provides functionalities of both stack and queue. In stack, you can insert and delete from the same end. In queue, you insert at one end and delete from the other end. In Deque, you can insert and delete from both the ends. So if there is a Deque which has certain items, you can insert here, you can delete from here, you can insert here, you can delete from here. Deque in C++ STL is generally implemented in a different way from other languages. In most of the other languages, it's implemented as doubly linked list. But C++ STL guarantees few extra things, like it allows you to have random access. It allows you to do arbitrary number of insertions in big O of one time, which is not provided by Deque implementations of other languages typically. So Deque implementation is really interesting. You may pause this video and try to think of an implementation that provides insertion and deletion from both the ends, provides random access, and provides insertion of elements at the end in big O of one time. Not big O of one amortized time like vectors, but big O of one time. Before we talk about implementation, let us look at the syntax, how Deques can be used. So we create a Deque this way, and we can initialize the elements of Deque here. If you do not initialize the elements, it creates an empty Deque. This thing pushes an item at the front of Deque. So this will create a Deque 10, 20, 30, these three elements. When you call push front, 5 will be pushed to the front of it. When you call push back 50, it will push 50 at the end of your Deque. 50 comes here. This is how we can traverse the Deque. There are more ways, like using iterator. This is a simple syntax to go through a Deque using for each loop. So we traverse through every item of Deque and we print it here. So the output of this program is going to be 5, 10, 20, 30, 50. Basically this thing. This is the output of this line, right? This line. Deque provides more functions to access front and back. You have Deque.front that gives you front item. So what will you get? When you call Deque.front, you will get 5. And when you call Deque.back, you will get the last element, 50. So here we saw creation. We can create an empty list, empty Deque, or can put initially some items. Then we talked about two functions, push back and push front, and then we talked about traversal and front and back. Let us now talk about more functions. Let us take a look at this program. In this program, we are going to demonstrate these functions: begin, insert, pop front, pop back, and size. Like other containers, begin returns you iterator pointing to the first element. End returns you iterator pointing to an element beyond the last element. Similar to other containers, there are rbegin, rebegin, cbegin, cend. Cbegin, cend are constant versions of begin and end. Using these iterators, you cannot modify the elements. Rbegin and rend are reverse iterators. Rbegin points to the last element, and when you do iterator plus plus on this reverse iterator, it takes you backward. Right, and rend points to an element before the first element, right? So they are reverse iterators, opposite of begin and end. Similar to cbegin and cn, which are constant versions of begin and end, they are crbegin and crend, which are constant versions of rbegin and rend. In general, when you are solving problems in STL, most of the time you do not need iterators other than begin and end. These two functions most of the time work for us. So we have got iterator, which is an address of the first element. Then we did iterator plus plus. So we got our iterator having address of this element 15. Let us now talk about insert function. Insert function has multiple forms. Here we have talked about one form where it takes an iterator and a value. And what it does, it inserts this value before this iterator. So your DQ is modified to 10, 20, 15, 35 and 12. Your iterator was pointing to this point, and when you called 20, it will insert 20 before the iterator that you have passed. Pop front, as you might have guessed, it's opposite of push front, removes the first item. Pop back, opposite of push back, removes the last item. So pop front modifies your DQ to 20, 15, 30, 5 and 12. And pop back modifies it to 20, 15, 30, 5 and 12. 5 only. 12 is removed. So this is what is changed from here to here by pop front. This is changed from here to here to by pop back. And from here to here by insert function. DQ.size, it tells you how many elements are there in your DQ. So at this point you have 4 elements. So output of this program is going to be 4. Let us now talk about internal working of DQ. DQ provides push front, push back, pop front, pop back, all these operations in big O of 1. All these operations are possible in big O of 1 with doubly linked list. But doubly linked list does not provide random access. And DQs in C++, they also expect random access to be big O of 1. So you can use circular array. With circular array, you can insert at front, delete from front, insert at back and delete from back. You can do all these operations in big O of 1 time. Also you have random access. Using the front and back indexes, you can find out the element at a given position. But the problem with circular array implementation is if your DQ grows beyond the capacity, then you will have to double the array size and copy all the data. And if your data is some user defined object, say if it is an object of student which has name, first name, last name and many other members, then this creation of double size circular array is going to be costly. So DQ uses some tricky implementation, and when it says big O of 1 time for push back and push front, what it means is it's constant time in terms of number of copy constructors called. So if your data object is some class objects which have too many things, then the idea is to minimize the number of copy constructors. And the number of copy constructor calls that happen is a constant. How does it happen? We use an array of pointers, right? And these pointers point to some fixed size blocks. I have considered 5 size blocks. So your DQ data is divided into some fixed size blocks. Here block size I have considered as 5. It might be 100, 200. So you have your data divided into these blocks. Your middle blocks are generally full if you have data more than the block size. And if you have only 5 items, then everything will be in the middle block. If you have more than 5 items, then some items will be here, some items will be here. So you mainly begin filling from the middle in this pointer array also or this array also. And then you grow toward both the directions, because you can do push front and you can do push back also. So this array, the first array grows this way. The first element is inserted at the 4, then 3, then 2, then 1. All the other arrays, they grow this way, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And when this becomes full, you take one more slot of your pointer array and change your begin and all the pointers and just make one more pointer here and have more data, space for more data. The only problem with this implementation is your pointer array might also become full, right? That you must be wondering, like, what happens in that case? In that case, it does something like we do in vectors, doubling or something. But if you take a look at this particular doubling does not involve copying the whole data. It involves only copying the pointers. That's the argument people give when they say constant time. They say constant in terms of number of copy constructor calls. So if your data is some class object, then you are saving the constructor calls which are going to copy the all members when you are just doubling the pointers. And for a large number of elements, you will rarely see a doubling because every block of this pointer array points to a big chunk of data items. So these will fill. Once all these are filled, then all the slots of this pointer array will be filled. Then you will need to double this pointer array. So this is one implementation which is recommended everywhere. If you look at this implementation, your pushback, it's big O of 1. Your push front. However, you can argue that this is big O of 1 amortized, but if we talk about number of copy constructor calls, then it's constant. Number of copy constructor calls happen constant. Your pop front is big O of 1. Pop back is big O of 1. Random access is big O of 1. We can access the element at given index in big O of 1 time. Because elements are at contiguous locations, we can do some computations to find the element at given index. We know individual block sizes, we know we have the begin, we have the end. And please remember, end points to the element after the last element, right? And you also have front and back references. So front refers to this and back refers to this, and end refers to the element after it. Let us now talk about insert and delete. Insert and erase. Insert and erase are obviously big O of n because it's a contiguous memory setup. And if you want to insert an item, even if you are given address of that item, you will have to move other things, right? And if you want to erase an item at random locations, some locations in between, then also you will take big O of n time because you will have to move everything to ensure that you have contiguous memory location and you can do random access in big O of 1 time. So these two are big O of n operations. Last thing, the time complexity of pushback and push front is arguable. You can say it's not constant in worst case because you have an array of pointers that you might have to resize. But there are few interesting things and that probably is the reason it's written constant in the standard. Pushback and push front, they do constant number of copy constructor calls. If you are using a vector to implement circular style, then that would have caused amortized or worst case big O of n copy constructor calls. But that does not happen here in this setup. Also, resizing happens very rarely because you have some chunks. These may be of big sizes, 100, 100, and then you have an array of these chunks, and this array is very unlikely to become full. You have lots of space that you can use to fill the items, to do push back and push front.